Well, thanks for coming. I'm Charlie Cuddy. I teach math at Omaha Bryan High School. I kind of came up with this idea a couple of years ago of trying to incorporate more methodologies for a tech type environment in our classroom. I spend most of my summers out in tech industry. I do internships. Did one at PayPal, did one at Agile, a software company here, and just try and get out and see how math could be applied so that I can bring it back to the classroom and not just teach out of a textbook. And so I have a 3-year-old daughter at the time, talking to her about some of the things I was doing, and she couldn't believe that I would let girls learn about computers. And I don't know where she gets this idea, and so it just kind of blew my mind. I was getting ready to start my master's project and decided to go all in on how can I get tech involvement in more schools so that there's other kids that felt that way, that they could be exposed to it before college, essentially. So the abstract is what's in the handout, so I'm not going to read it to you, but it's just kind of the general idea of what's going on here, how to take a math classroom and make it more Agile friendly. So kind of handful of things I'll chat about is just brief intro to the research I did for a couple of years with my class that allowed my principal and some of the people at the district office to approve the class that I'm currently teaching. And then jump into how to get running on Bricklayer if you want to implement the program here. It's a local nonprofit developed by a couple of professors from UNO, Dr. Winter being one of them. And so show you how to do that. You can go anywhere from a day activity to I teach an entire year course using it at the high school level. I know it's taught down as low as like 2nd grade, 3rd grade, somewhere in that range. So then how I use that class to create that Agile environment, let the kids kind of set their pace, control their learning, and prepare them for jobs outside of high school. And then show a couple of the other things that really easily are available with Bricklayer and some of the resources I have. So we'll start off here. So the question I asked for my master's research was, does implementing computer programming in an Algebra 2 classroom increase creativity and problem solving as well as participation? And so those were kind of hard to quantify at the time, so we had to kind of think of ways that I could make that work. The number one thing, like I said, was this idea that coding jobs are growing crazy. They're not being taught too often in a lot of our schools, and I just didn't feel like I was preparing my students when they constantly would ask, how am I going to use this? And I basically say, the only time you'll ever use this is next year in this next math class, which you have to do to get your piece of paper so that you cannot use it anymore because a computer will do it for you. And so I wanted to give them some background on what the computers would be doing. So in Omaha Public Schools, we level our questions, with the level 4s being what we call like more of the higher level questioning applications. And so you can see of my 40 students that I had in my study, all the units combined, only 3 students ever attempted a level 4 with this class that I did my study. After we introduced computer programming for just it was like I think only a month and a half, 2 months. In the units after, we got up to 12 students and went from only 4 total problems ever that I needed to grade up to 21. So that was kind of the way that we justified their ability to problem solve, think creatively on some of these higher level problems that they wouldn't necessarily have approached before. Some of my favorite questions I asked them was just, did you enjoy coming to math? And as you can see here in the yellow, that for the most part, the not liking went down and the liking it came up, which was exciting to see. But I think this was one of my favorite things that I found in the study was their ability or want to talk about what they're learning when they're not in the classroom. And all the time would say, hey, I was telling my mom or my dad or my grandma about this, and can I take some screenshots of this to show them, because we don't have a computer at home, and those types of things were really, really awesome, and doesn't typically happen when you're doing long division or polynomials, so that was cool. This also kind of blew me away. The homework completion based on assignments in the units before was 22. In the units when we did coding, kids were actually requesting homework, 114 completion percent, beyond what I was assigning for stuff like, hey, I got this done early, what else can I do? Which was, I was expecting it to go up a little, but not more than what I was requesting, so that was pretty sweet. Okay. Oops. So, Bricklayer is available online. I was selected to do a fellowship the year after my master's through DoSpace, and so I had put together kind of a linking to the Bricklayer website, the steps that I took in how I used the site, so you can kind of follow along what I would have clicked on in what order. Obviously, multiple ways to do it, but that was just kind of how I went about it. So, just for a quick minute, bounce over to their website. They have all kinds of different apps, and I'll show some of the ones that I like the best, but then they also have some great teacher resources, some sample curriculum on how it ties into what you're doing. Also, up here they have different news articles and then other presentations that have been used in other grants and things along those lines that are really easily available. The site that I put together here is essentially just, I broke it down based on what I knew my principal would like to see and kind of the orders of what we were going through. And so just numbered them here. I start here with 1, 2, and 3 different projects that you could link to, some examples of how to walk through them. And then how to actually go through and download if you wanted to actually go outside of the browser, download the software onto your computer, what you need to get up and running. And then I went and linked to some of the code-alongs or videos that they have, some documentation, those kind of things, and then also linked to any of the projects that I had built in my class, so you can get on, see the code, straight copy and paste it and put it on your computer and manipulate it so you don't have to recreate things. So, I kind of divided my class up into 3 different ideas, and that's kind of where we'll talk with this Agile approach. A small project is maybe a day-long project that a student could do individually. A medium-sized project would take a couple days, typically 2 or 3, and then a larger project could take upwards of a couple weeks to a month. We split it up into several different sections. Students take on different roles within the team, and we meet back and kind of go over that. So that's kind of where this is going to go from here. So, oops. So very first thing that I always introduce is that it's this idea of a grid. It's like digital online graph paper, where students can go ahead and move around pixels, but it really has a lot more involved. So to not get too crazy, but just a couple little demos of what's going on. You can shrink and grow this graph paper however you want. So often I did this on graph paper, like on physical graph paper with colored pencils, and then a student would make this elaborate thing, make one color, turn it into green, and they want it to be purple, and 30 pixels are done, and they throw it in the corner and they pout and are done for the day. And so this has been really nice to, if you just click on your color where you want it to go and you decide, oh, I want it blue, you can just override it. But some of the pieces that are great, even for just introduction math classes, is this idea of your coordinates. So as you pick a point, it'll tell you, here you are at 1, 1, it tells you the size. For the most part, in those first early stages, you can tell them to kind of ignore this, but know that that's where the programming side of it is going. And it's really fun to start having these conversations later on about like what happens here with this third dimension. How does this look? And students start talking about like the graphs coming at you and those types of things. And so there's a ton more. I think Dr. Winter's going to give a talk on the stuff that you can do here, but you can essentially go through and a lot of this stuff you can see like the order in which they placed them, so you can follow along and see what the student, how they visualize the photo, and those types of things, which are nice, and recreate them there. Okay. So one of my students, actually this was I was working with Girls Inc., and this is a 6th grade girl that just sat there the whole day, and this is all she wanted to do, but she was looking at the coordinates, and the part that's awesome is it really allows you to differentiate instruction really easy. A student can essentially click on squares, and whether they know it or not are plotting points. And in my classes, we start having conversations about the idea of like how slope can be affected between these 2 points. And then when you get to Bricklayer, those 2 points will be connected with the different function calls and create lines and those types of things. So, that's great. Bricklayer has this thing called Vitruvia built in. It's basically like a self-paced ability for students to get immediate feedback on if they're placing them in the right spot. So I picked just like the very first one, where it essentially, and it's really small, so I just blew it up here. Hey, can you put a green block at these spots? Okay, so student grabs the green, comes over here, puts them in the correct spots. Hopefully here, you hit submit, you get fireworks. If you don't, you have the option to show your answer, or to show the answer. You can retry and try it again. Oftentimes, I find the biggest mistake that students make is not actually the placement, but they overlook like it said green and they made it blue, and they're like, I know I'm putting it in the right spot. And so it's just a fun little conversation to have on like how little things, especially in programming, can have a huge impact on the whole program. So. I just wanted to click on the site that some of these are a little bit more involved. You can see that they'll start changing size. Like now it's a 3x2. And so instead of having a 1x1 block, we want a bigger block. And so we have the discussion on, okay, if you're putting a bigger block at 0, 0, how do we arrange a 3x2? So we start referencing the bottom left corner will be the original coordinate, and then everything is into place accordingly. But the main thing I wanted to point out was throughout some of these concepts, there's YouTube videos to kind of walk you through if you're getting stuck or the students want to see someone else. I know my students love to hear someone else talk every once in a while. So this is where it shifts a lot out of the just clicking on the pixels and more into the actual coding part of the thing. So if you've ever worked with Scratch, where it's the drag and drop code, that's essentially what this is. It's all still browser-based, so you don't even have to download anything to get this up and going. So over on the side will be all of these little options. They're nice. They're in the order that they need to be right now. So the student just drags it over onto the playing surface here, essentially, and open the level. You have to build this. The build 2D. It's essentially the base plate, so you can really, I mean, if you have Legos and you have a base plate, they can physically be building these things right there. So you got to say how big you want the base plate to be. You start saying the size of the block, so 2x1, 3x2, and so forth. One thing that, as we go through our programming class, like little semicolons or things like that are like the biggest thing. They make this elaborate thing, and then you miss one semicolon, the whole program won't run. They freak out, they're changing all these things, and it's like there's just that one issue that is playing kind of a part. So we try to kind of talk about that here. They leave that empty Lego space here so that you have to go through early on in the idea of ending the line with a semicolon to let the computer know your line is complete and stuff like that. Another thing that's really great about this, there's different levels, and you'll see they have the levels, and then they'll tell you, hey, these are the Vitruvia exercises. In order to be successful here, you should really check out and make sure you've passed through these levels, which is great. You have the ability to download your creation. So we use Microsoft Teams, so my students download their stuff, submit to a file. Other students can look at theirs, can load them. That's how we'll go and we grade everything or turn stuff in there. I just wanted to pull up one of my students that I thought was really pretty awesome here, if I can find it maybe. I'm looking for my
desktop.
Yeah, I was going to say, do I have it? Oh, it's on the desktop?
Yeah, so I'll find it for you.
Sorry, I always use Apple.
Oh, okay, yes.
It's like having thumbs.
I know, I'm like, all right.
And there it's in there somewhere.
Yep, right here. The Brazil XML. The one down. There you go.
This one here?
Yep. So we had this idea of talking about, a bunch of my students are from a bunch of different countries, so we talked about using an opportunity to talk about that. They were able to build out like their country's flag, or they could pick their own flag. Some pick their favorite sports team's flag or whatever. So we built flags just because it was a nice rectangular shape. And then we talked about, well, how awesome would it be we build this one flag, if we could repeat it somewhere else, and the idea that you don't need to write all the code again, the computer's got it, we just have to call it elsewhere. So we got into this idea of parameterizing functions. Instead of giving a specific location of where this flag needs to go to input a variable, and then you can plug in a number later on, calling it multiple times. And so this student ended up using Brazil and Jamaica to go through and create this tiled pattern. But it's pretty cool. If you look through the code here, you'll see he essentially made one Brazilian flag, and then he made the little circle thing was annoying for the Brazilian flag, but the other parts of the code aren't too crazy involved to create these. And then afterwards, he essentially just made a row. So he made one row, put all of those 4 flags in a function, and then called the row throughout the top, so that he could tile it a little bit easier and not have to call all of them. But down at the bottom, you'll see where it allows them really to see, like, okay, if I put a 0 in for row, now my x in row is 0, and it can see the math kind of come to life there, which is really great. I have a wide range of students in the class, some lower level, some that were actually taking like AP Calculus, and it was a pretty fun moment. One of my students, she graduated top of the class, and it wasn't until we were doing these where she was like, so this is like composite functions from Algebra 2. I'm like, yes, this is exactly that. So yeah, that was fun. These are some of the other ones that they created. I put these two side by side for a read. Like, this is a lace that repeats in on itself. So if you follow this along, it's all connected all the way through. But this is the exact same one. We just changed the colors so that when the colors were changed, you can a lot easier to understand where the patterns came and how they repeated the S shape or the sideways S shape. And this was just one of the ones that finished the project early and asked if they could make something cool. So here is an example of it. Okay. So then it kind of shifts towards Bricklayer. So when we're in the browser, it's a lot harder to really get a feel for 3 dimensions because we can't really see it. So we have to shift out, and that's where the downloads come for downloading Bricklayer. We use Lego Digital Designer, or for larger ones, we'll use LDraw. All of those are linked on here, and I can get them to you. But the LDraw essentially allows your code, instead of it being pixelated, to be like little Legos here. One thing that, if I can not break everything, if we come back to wherever I was, for the Bricklayer Lite, the thing that I think is really, really handy, and this is where I was talking about the differentiation that's great, is a student who's comfortable with Bricklayer Lite can continue to code here, and output at the bottom is the code that they will need for Bricklayer. So they simply click in here, copy it, and paste it into Bricklayer, and now they can get the same 3D image that everyone else was getting without actually physically having to type it until they're ready. So I'll have students late into the year still doing a lot of their code here and then transitioning until eventually there's like that aha moment where they're like, wouldn't it be faster if I could just copy and paste this here? And like, that sounds like a plan. That happens over here, and then they make that transition on their own. So just a quick little demo. I don't want to get too crazy, but this is essentially what that picture from the slide was, where you've got different circles in a 2D plane with a radius, a color, and the location being the center of the circle. So you can run this thing. Maybe. Yeah, I was going to say it's going. Here we go. So we'll run it. And then the conversations that become pretty cool are like, okay, so here it is. I can move around. I can see it. But again, what if I wanted to move it? Like, okay, I've just typed in all of these numbers for it to be centered right here, but I actually want it over here. And so to have to come back and essentially change a 7 to a 9 and change a 7 to the 9 and change it's a tedious process. You can use replace like you would in any other document, but a slightly more efficient way was this idea of let's create a function. And so one thing we do here to create a function is I just called it target. I put all of the code inside and I removed the numbers. placing in a parameterized idea of this x plus the 7. So now if they want to change everything to 9, they don't have to physically change it to 9. Down here when they say let's make a target, they would just do this to 2, and then the math happens within the function. Another thing we talk about doing is things that we maybe could go through and do is like, instead of having to put a 14 in here, we could create a variable called size, and then we could change the size in one place. It changes all of the places and those types of things to adjust the radius, which is pretty nice. So one thing we could do here is like, size -7, size -6, and then if the radius gets bigger than the size gets bigger, all of the radii would adjust accordingly. And then the last thing that I think is really pretty cool is you can start adding in other variables. So we took this idea of target, and instead of having 2 targets, or if I bounce back here for a quick second, so I called target twice. So when I run it, it will show up the twice, and maybe we can do that quickly just to. I don't want you to think I'm a liar. So now the code got ran twice, but I didn't have to write the code twice. I just called it twice. But the idea is, well, now I've got this black and red target repeating over and over again. And so we can come back to this here, and it was like, well, I've done all of the code. I want all of it to be the same thing. I just don't want it to have to be red and black. And so again, we have that idea of, well, you can just go through and change all the red to pink and all of the black to green, or whatever the case was. But you can also just, inside of target, add in here some other kind of variable. Essentially, we called it color 1 and color 2 because we're super creative. So, and then instead of doing red-black alternating, I just did color 1, color 2 alternating. And then when you call your target, instead of saying just the location, you say the colors that you want to get plugged in. So it plugs in the colors, and then where color 1 is accordingly. So now you're running the same code, just inputting a couple values, and you get the same thing, but just output in a bunch of different colors. And another rabbit hole you can go down with some of the conversations in YouTube that's really cool is this idea of using circles, but in a pixelated sense. I mean, maybe you can kind of already see like the idea of squares showing up in here, and different lines. You start overlapping them, and it almost turns into some kind of like distortion. That some of the stuff is really pretty cool. So these are a couple of the things that we built in our class. We actually talked to architectural firms, got blueprints, made our cafeteria to scale, made other rooms in our school to scale. This group here built a scene from one of their favorite video games. This group was really big into like fantasy, and so they built their whole world as if it was a floor of a forest floor. But all of these are like hollowed out, so you can go inside the log. They have tables and stuff inside of here, and go inside and see it. They called it library and all kinds of stuff. So it really is pretty nice to let them just kind of take control of what they are wanting to do. I built this trying to teach myself how to do it. So I, as part of that fellowship, built Memorial Stadium down in Lincoln. So the way that I kind of set up the classroom, this is essentially what our day, semester, year looks like in our Agile classroom. So we have what we call as a daily stand-up. So kids come, log into their computers while I'm taking attendance. They write what they did yesterday, what they're going to do today, and then if they have any needs. So while they're kind of getting organized, I can just quickly glance at this one living live document they all have access to, see where the biggest needs are, so I can kind of address those and not waste any time getting to people that are crushing it. It's also nice, it holds them accountable. Oftentimes, I mean, I just tell them, like, you're not getting graded on this, just be honest with yourself, and there'll be times like, I wasn't having a good day, I didn't do anything, and then they're just like, I need to work harder today, and so it's just a nice reminder, like, when they're like, hey, I'm behind, like, well, let's pull up your logs, what have you been doing? And they pull them up and say like, oh, I had 2 days where I didn't do anything. Okay, well, let's address it. So we used Slack last year because it's just a standard communication tool that's used but we used it enough that it got blocked in our district, so we started using Teams instead. So we're doing that now. So on any kind of project, essentially we create a backlog like you do in an Agile methodology of, I like to think of it as think big. We find our groups, what is everything that you could dream of that you want to be in this project, and basically it's just a rule where you can't say no. So someone says it, you write it down. It's going into the backlog somewhere. So we create it, spend a decent time doing that. Once we feel like we've hit there, we move on, we prioritize what do we need to get done in the next 2 to 3 days to feel like we've been successful. And we kind of cross-reference it with, I have like rough rubrics that I will use on different projects of, this is what I want you guys to do, but make it better. And so it's kind of up to them to prioritize what they think is important in order to meet the standards. So my first year I did this, I was pretty literal with what I was expecting, and then I got all the exact same projects. I was like, this is boring. I don't want all the same projects. I want you to do your project. And so I've become a little bit more vague, and it's actually like far exceeded my expectations. So. And then we break it down. So we take all of these prioritized items. We used, like, at first we just did sticky notes, but it got messy, and then other classes, I don't know, ate them or whatever they do in the other classes. And so we got on Trello instead, which is a great project management tool. It basically allows you to create columns like you would in I don't know how familiar you are with Agile, but we just have our columns, and then we drag and drop based on where we're at in the process. So we'll create this backlog. After prioritizing it, we'll set the backlog, and it's essentially numbered. Well, we don't physically number them, but we put them in the order of our highest priority. And then we assign roles where people think they could be comfortable, where they could become the most useful, and they drag from the backlog into their personal in-progress folder in Trello, so everyone in the group knows who's working on what at what time. If they ever come up with an issue, that's where it pops back up into the daily stand-up with their needs. People on their team don't have to be interrupted if they're in the middle of something by a question. When they get a free time, we glance at it periodically throughout the day, and then we can bounce back and see if they got whatever they needed addressed. It's been a pretty awesome little project. So we also post all of our stuff to teams. So like in one of the classes, somebody made a staircase, and somebody else was trying to make a roof, and they're like, hey, I think if you just use my stairs and adjust the slope a little, the code's pretty much all there for you. And so they can get on and pull it from there. One other thing with here, we always have a project manager for each group. And so that allows me to check in with, instead of checking in with all 30 people like one-on-one, I like to check on with the project managers. It rotates like daily, so essentially we have a new project manager each day, so I get to have one-on-one time with everybody in my class, but maybe on one day it's just 4 or 5 other kids. But they first meet while I'm doing the attendance and they're doing the stand-up, and then they, as a project manager, bring any needs of the team. I address it with them, and then they take it back and they figure it out amongst themselves, and then I obviously step in if they can't get that done. But the one-on-one was hands down the thing that I've learned the most from tech companies, and the time that you get the most back from your students is just seeing how they're doing on that one-on-one time. This is kind of just a visual. This is directly from our stand-up. So worked on creating letters, transformed. I just need to finish more time. It's really helpful for me too to kind of plan. If they look like they're on track, then we stay on track. If a bunch of people are stressing, then I just tell them like, hey, everybody, quit stressing. We're going to do another day of this, and keeps them there. This is another one. Like, she let me know she had computer issues. I didn't know about it, so it was nice. And then this is essentially Trello. So all of this at the beginning would be over here in a sprint or in our backlog. The project they're working on right now was every student or group is creating the alphabet, but they're standing up 3-dimensional letters. And so one person's making like 3 or 4, but it's the idea of communicating that we want our functions to look the same, so that when I give you my A, B, and C, and you give me your D, E, and F, I can know exactly what your stuff is going to do because it's doing it the exact same as mine. And then other things that aren't as a priority of, like we talked about with those targets, being able to change the color quickly if we want to, and those types of things. But then essentially the project after these all get done, and I can check everyone's Trello, and I start seeing all of the letters showing up over there. We can kind of shift to the next one, which one of the small projects, they'll write their own name. One of the larger projects, they'll write like a poem or a quote. We usually try and tie in with one of the English teachers that is in the hallway with me of what they're working on. And then they reference back to their write-ups, or to their stand-ups, to do a formal write-up at the end, so they can get an idea of how much time they spent, what they put into it, so that we can better anticipate how long they think that they'll need on the larger projects as they come available, so they can kind of see their growth and stuff like that. Okay. So this is one group. you can see his name, the letters they've created. They're kind of joking around that it looks a little ransom notey, so they wanted to kind of pick it up a little bit. But this is what it looks like in teams. We just have folders of each individual project that we're working on, so they can turn them in as they complete them. If one isn't that exciting for them, they jump to a next one, then they just come back and finish it up another time. If they're gone, like I have a girl that's in Pakistan right now for vacation until January, and she's still participating with our group, so it's pretty cool to be able to do that. This group just wanted to have an Excel sheet of their Trello, so I was like, as long as you're tracking it, I don't really care how you're tracking it. Last kind of thing is all the stuff that you do can be 3D printed, and so I applied for a grant, got a 3D printer in our school, and so this is a tower that someone built last year, spheres. There's the football field that I was building. You can kind of see this is code, this is in Bricklayer, this is in the Cura that we use for 3D printing, and then that's a 3D printed model. So they were eating this up when they sit there and watch their stuff be printed and take home and all that. We printed Memorial Stadium, which took like 50 hours to print. It's pretty wild. All of it can be rendered into Minecraft as well. So they think that's pretty awesome. You throw your stuff up in Minecraft. We do a little end of the year thing where Dr. Winter brings in his HTC Vive, hooks us up in virtual reality, and you can walk around inside of all of your codes. So took a tour of the Bryan High School. We went inside the mushrooms in the book that the students had built. It was pretty sweet. So this is kind of how to get a hold of me. The websites that I have all my code posted on GitHub. This is my action research paper, YouTube video of the Memorial Stadium, my fellowship, and the Bricklayer stuff. So I don't know, I have like a few minutes if anyone has any questions or anything. Sorry, got a lot of you. Teaching downhill is what I always call that.
So on the rotation, you said that somebody's a manager, every class meeting it's a different manager. Do they figure out amongst themselves, they take care of all of those details? Or?
Yeah, unless they can. I mean, essentially, you guys have got 5 people here, so you got to figure it out. I mean, have you done it before? Yes or no? So, but in one of the groups, they struggle with it, and attendance can sometimes be an issue also if we have some attendance issues in the class. But it's not a cut for like, no, you've been project manager, you can't do it. If the person's not there, someone steps up. But we just, we tracked it last year, and now that you say that, I'm not tracking it this year. I don't know why. So yeah, usually I just kind of keep a little tally mark in their Trello. But.
What did you do to get this up and running in your classroom?
Yeah.
Really, you put a lot of time and thought into how to organize this and develop an entire course based on it.
Yeah, so I took all like my research from my master's and showed like our principal, kids want to do this. They're interested in math. And so that got him listening. And then I did that fellowship with DoSpace and spent like 300 hours learning how to get this going. And 300 hours is way more than you need to do. Like you could get it going in a weekend if you wanted to. But I don't know. I think I just got really lucky that my principal was really supportive. He's like, I like the things you do in your classroom, so let's give it a shot. If you can fill the class, we'll try it. And we filled the class, and kids are loving it. So essentially what I did for it to be, because it's right now it's being taught just as a math class, because I only have, my master's is with math, and so I can't technically do the computer science side of it. So we found a math class that was on the books, not currently being taught at our school, that hit the standards in here. So talking about functions, that we're talking about slopes, plotting points. I mean, any intro to a math class, but I mean, it touches on all reflections, all kinds of stuff in geometry. And honestly, I like having it all as one class, but I really think that it would be so powerful if you could take pieces of it and have a unit of it in geometry, or have a unit of it in algebra. And then, I mean, some of the kids that really want it all in a year-long is awesome. But I mentioned in another group, like just like the idea of we made a cube and we wanted to 3D print it. We saw how much filament it was going to take, how long it would take. And so we talked about like, well, does it really need to have anything on the inside? And so we cut out the inside, made it hollow, and saw the load time on here and the amount of filament that it would take. And so then we were able to have some great conversations about the relationship between surface area and volume. And so, I mean, there's lots of different things that pop up with it. If anything comes up, you can always answer email all the time. So, yes.
So many times, really good ideas get stuck behind the idea that we have to ensure that our kids are learning certain things for tests. How have your students, you've had great data at the front about who liked math and et cetera. I'm sure you have charted how well they do on whatever tests you have to do?
Yeah, so we've kind of designed the tests around this for right now. But the one thing, right now it's an elective, so they're required to have hit their minimum graduation requirements to take it. So it's currently a lot of the higher level students, which is unfortunate because I think if we could get it to lower level students, they would be way more interested in becoming higher level students. But the part that's been awesome is they talk about how they'll directly relate this into the algebra part. I mean, with the composite functions and stuff that I mentioned. But to say that it was like actually quantified, we haven't done a ton with it because we've been developing it as we go right now. But I have no doubt that it would improve those things, just positive and negative numbers. I had 3 kids that were put in my class last year because it was behavioral issues. And they stayed in my class for 2 or 3 classes instead of going to their others and just were crushing stuff.
Just
so.
a behavior issue.
Yeah, and then all of a sudden they're getting more done there than they've done. So that's one thing.
I believe it's going to make a positive difference, and I think that the sooner we can prove that to the people that look at those numbers, the better.
Yeah,
we'll have.
I agree. I know Dr. Winter we were working on we had a pre-test and a post-test that we gave for the first time this year on just spatial recognition, 3D modeling, and symmetry, those types of things.
So kids take it in their senior year?
Yeah, I have juniors, seniors, and then I have a few sophomores.
But they all have completed their math requirements?
Yeah. Except for him. There's special cases.
Yeah. I'm sure there's a way you can even prove it with tests they already give.
That's what
That's going to be better. That's going to make believers out of more people.
Mm-hmm.
Good for you.
If honestly, if there's anything that interests you, if you even want to try it for a day or a week, reach out anytime. I'll get back to you.